Okay, good morning. So today we start properly delving into the syntax, the rules, the opportunities within Python. So this is one of our CT lessons, computational thinking, where we explore the tools and techniques for learning Python. Today we want to make sure we can tell apart different data types. So you'll be able to recognize these and tell the difference between them. Everybody needs to remember the definition of a variable today. And we need to make variables and use variables, and then work out how we can use Thonny or Moo or Create with Code, our integrated development environment, so that we can track how a variable changes. So we've just discussed what a variable is. It's a memory location, something stored on a computer that can change. And it can store different types of data. It can store a whole number. It can store a number that's not a whole number, like 3.2. It can store a whole word, like potato, or an individual character, like P. Any of those can be stored in a variable. We've already worked out how to use them, but we want to look at different data types today. So I'll leave this on the screen, I'll pause the video, and we'll discuss which one's an integer, which one's a character, which one's a string, and what on earth is the other one. So we've discussed that this is an integer, a whole number. This is a float or a real. This is a Boolean, and this is a character. Notice you cannot have spaces in variable names. If you do, it breaks your Python code. So you've got two choices. You either go for camel case, which is like a camel with a lump on its back, or you go for snake case, which uses underscores in between them. Doesn't matter which you use as long as you're consistent. The inventor of Python prefers you to use snake case, but the exam board seems to prefer you to use camel case. So we'll use camel case. So these are the main ones here. If you use the wrong one, then you see this kind of error, which we'll come across quite a lot in today's lesson and learn how to fix it. I want you to be able to use the IDE tools. So your job, please, you need to find your CT3 worksheet from the VLE. First of all, write down as many of these as you can work out what they do. And then open up activity 2 in Thonny. We're all going to use Thonny. Some of you said you preferred Moo. We're all going to use Thonny today. So open Thonny, copy and paste this code in, and try and work out what these keyboard shortcuts. So these keyboard shortcuts are really useful. In computer science lessons, we don't rest our head on our hands because we are never in a state of despair. We see mistakes as an opportunity out of frustration rather than a route into frustration. Both hands, one on the mouse, one on the keyboard, or preferably both on the keyboard. Control C is copy. Let's experiment with them and explain why they're so useful. So Control C, and then that goes nicely with Control V, so you can make a copy of it. I'll also like you to add in 2 extra lines. You don't have to do this, but it's helpful if you want to get the awesome or the excellent for this piece of work. And that just explains, like, Shift and the arrow keys changes the selection. Notice it's selection, not a highlighting. Change it if you've written highlight. And home and end, go to the end or the home of the end. The line, sorry. Explained that before. What I haven't explained before is control and arrow keys, which jumps one word, which is really useful for changing the selection. I find the effort involved and the time involved of lifting up my right hand, placing it on the mouse, moving my mouse, clicking, picking up my hand and putting it back on the keyboard. I find it irritating, frustrating, and inefficient. I want to use the keyboard as much as I can. Control A does not highlight everything, it selects all, selects everything. Most useful shortcut for question 2 or question 3 in the exam is Control X. Rather than Control C, Control V, Control X will cut. Think of an X like a pair of scissors with your fingers. It means that you don't end up with extra copies of something, you can change the order of something. Seen a couple of gaps for Control F. It's find, and it works for most programs. So I would strongly recommend, if you haven't already, that you just pause for a moment and find at the top of the VLE the PLS, Programming Language Subset. This is what you get a digital copy of and a printed copy of in your exam. You've got a 2-hour Python practical exam. You'll do a mock in year 10 in the summer term, and you'll have the actual exam at the end of year 11. You get a digital copy, which means you get this actual PDF in your exam, which is brilliant because you can Control F. and search for things like integer and find the exact page within the 16 pages of Python reference that tells you what it means. So if you want to search for how to do something to do with strings, you can Control F and enter, and it tells you all of the stuff you need to know. I'm not expecting you to understand or remember this PLS, but we will refer back to it because you have a copy on paper and on screen. So Control F is really useful. Control N makes a new one. You won't have access to a printer in your exam. We'll rarely ever print off anything. The only reason you might want to print something is if you don't have access to a computer at home. You can print off your probably your P homeworks, and then you can do them on paper. You're welcome to do that in your lesson. Oops, Control Z doesn't do Control Z. It allows you to undo a mistake. So let's have a look at activity 2. I've filled in some reasonably sensible suggestions here, but there are some mistakes. There's a lot wrong with this code. We'll run it and we'll see. First thing, never be afraid of the red text. The red text gives us some clues and it tells us to start looking on line 5. And it says there's something wrong with line 5. Video. So we need a capital letter for true or false. Now we can continue our debugging activity and track down an error. Notice you'll only, the debugger starts from the top, and if it gets through these, then we'll find another error on here. So we need to have quotation marks. You can either use single quotes or double quotes. What you can't do is have one of each. They have to match. So this is a character, and this is a string. An individual character is just one letter. It could be a number as long as it's in quotation marks. That's an integer and that's a character, and they are different. So now we have two problems here. One is a runtime error because it's not a syntax error anymore. It tries to run the code and then crashes because it tries to do something impossible. And there's also a logic error. We'll talk about the logic error first because the bill that you pay should be nothing to do with the gender. That's not very equal and it's not very fair. But the logic error, the runtime error means that we can't concatenate, we can't join together bill paid and gender because they're different types. So your job is to convert bill paid, which is a Boolean value, into a string. So we wrap it in brackets, parentheses, the Americans call them, and put str in front to convert it into a string, so that we can concatenate, which means join together with this, which Python thinks of as a string, but your exam board thinks of as a character. Notice at the bottom of activity 2, it says explain what happens. That's your job to say why you can't join together these two because they're different and what you had to do about it. So let's have a look at activity 3 together. This is the type of thing that you might have to do in an exam. It gives you instructions on a written piece of paper, and each bullet point is usually something that you've got to try and work on. So this is very similar to a question 1 style question, and there are 6 questions in your on-screen exam. So what I would do is copy and paste this into Thonny, Control N for a new thingamabob, and turn each of these into a comment. So we'll put a hash. I really like a space afterwards. I think it looks smarter, but it doesn't really matter. Our first instruction says giving a suitable comment heading. So this is my suitable comment heading for each one. Some of you will realize if you press run, it won't work until you save it. So you need to think about a sensible name. This is activity 3 for CT3. So I'm going to call it that. CT3 activity 3, and it will put a .py for Python on the end. I'm not going to do all of them, but let's make a start. Oh, I don't know why the syntax highlighting's gone dodgy there. That's interesting. Weird. So we'll make an integer variable. We can do that just by giving it a name. So that's its name, Control C, Control V. I double-clicked to select a whole word and assign it the value 0. Assignment is just a single equals. That's all we've got to do. Remember, I like a blank line above a comment, unless it's right at the top, so it's crystal clear that this is describing the code underneath it, not the code above it. That's all you've got to do, really. Make a float called track length and assign it the value 34.12. I'll put details of an extension on at the bottom of my Word document because I don't think this will take you all that long. So when you finished activity 3, it's worth getting familiar with the tools in Thonny. For example, let's just do this one. So track length, if I can spell it right, is equal to 34.12. You can run the whole thing and you see the output from it here. There is no output because it never has anything that says print. Or you can debug the script, which means run it line by line. So Control F5 will now say, well, I'm just about to run this, which means you can step over one line at a time by pressing F6 on your keyboard. Why is that useful? It's useful because if you go View and Variables, you get this window up here. It shows you what is stored in each variable, and that's exceptionally useful. Maybe not today, because we're setting it once and then it never changes. But you can press F6 and step through and see the value of every variable. It's really helpful. The extension today, though, is on the VLE. You have a link here that says Algorithm and Programming 1, Variables, Constant and Assignment. This is everything that you've been doing, really, but you get instant feedback to see if you've got it right. If you click on Variables, this is exactly what we're doing. Let's try it. Come on, Variables, here we go. Create a variable called model number and store the string value 123. So model number, probably going to get a point if we assign a value to that. But if we set it to 123, we're not going to get all of the marks available because it's not a string. The data type is really important. If it asks for a string, it has to be a string. And then you can just work through each of these and try and get the points. If you want, you can skip ahead and have a look at constants. The only difference between constants and variables are constants are in capital letter. The idea is that a variable can change whilst your program runs, but a constant should never change. Like pi. Pi is the same on Mars as it is on the moon, as it is on this planet. If we want to store a value that doesn't change while your program runs, we'll put it in capital letters, which tells the programmer, do not change this value. Let's see if that works. It kind of works, but I spelt it wrong, so I haven't actually set it to yellow yet. That is your extension. Let me put that, the description of that, at the bottom of the VLE, sorry, at the bottom of your Word document so that you know what to do at the end of activity 3. The extension challenge is this link on the VLE. And when you've saved your Word document, remember to save and close before you upload, but you upload it to Half Term 1 Algorithms and Programming at the end of the lesson.